All right, one more absolute value inequality. What you want to do with an absolute value inequality is you want to get that absolute value all by itself. So if you're dividing an entire chunk of stuff by one number, if you're dividing an entire side by a number, multiply both sides by that number. That allows the absolute value to now be on its own, like that, the twos cross out, and that's going to be greater than or equal to 10. Now, what you're going to do is you're going to split this up into two inequalities, okay? The left side of each inequality are exactly what appears inside the absolute value. Don't change it. One of the inequalities is going to be greater than or equal to, so keep the sign and keep the right side. The other inequality is flip the sign and make the right side its opposite. What we're missing is a word in between. So you want to memorize the phrase great or less than. Now, what this does is this helps me remember that the moment I split these up into two, I look at that inequality right there, and that's a greater than symbol. So I'm thinking great to or. So what's the word that goes in the middle? Or. So just like we've always done with compound inequalities, you solve each one individually. So minus 2, 3x is greater than or equal to 8. Divide by 3, divide by 3, and you get x is greater than or equal to 2 2/2, 2.666, whatever. You do this guy the same way. Minus 2, cross you out. 3x is less than or equal to negative 12. Divide by 3, cross you out. And that just gives you a nice x is less than or equal to negative 4. Again, the word in between is or. So what we care about when we graph this is numbers that's bigger than 2.6 repeating, or it could be smaller than negative 4, and you're allowed to include these numbers. Now, when you have an or statement for a compound inequality, you can put both lines on the same number line. So let me label this 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. There's my negative 4, negative 5. If I wanted to graph this guy right here on the left, okay, I'm going to say, all right, well, 2 2/3 is going to be right around here, so let's put a circle around here. Why am I filling it in? Because it's equal to, and we care about any number to the right of it, greater than that, so we're going to shade everything to the right. Bada bing. What we care about this guy is everything at negative 4 and smaller than that. So that's our answer. I mean, anything that lives within the red or the blue is a possible answer. So if I pick 5 and plug that into the original equation and did some math, I'll get a true statement. If I pick negative 5 and plug it into the original problem and do some math, I'll get a true statement. Okay? Compound inequalities, absolute value inequalities, they're all the best.